All right, if everybody can take their seats, I have one logistical announcement that Tracy just asked me to make. The team has lifted the limit of having lunch with speakers for lunch with only two speakers. So if you signed up for lunches with two different speakers throughout the week, you can now sign up for more if you like. And they're gonna put the link in the general Slack channel. So you can go there and sign up. And again, you would pick up your lunch at the tent outside and then head to the Hamitman Center. And I'm sure that there'll be people to guide you as to where to go. And then these lunch with speakers are actually really valuable. If you're afraid to sign up or something, don't be afraid. The speakers are really happy to talk to everyone. And this is kind of the point of these workshops, right? The point of these workshops is to really connect the folks that are somewhat new to the field, with, oh, Todd, I love your dog. Sorry. I saw everybody looking at the screen instead of me, and I'm like, what are they looking at? Oh yeah, it's Todd and his dog. Anyway, please do consider signing up, right? This is a really great networking opportunity. The speakers and lunch with speakers and the workshop in general. So I know it's really hard for some folks who are very introverted and they're worried about asking the wrong question or saying the wrong thing. Don't be. This is your opportunity. And all of the speakers that are donating their time and their talent to be here were once in your shoes, and they want to be here. They want to help everybody. So, okay, I'll get off my step stool now here, my platform. All right. So next we have a panel on what is a planet, and Eric Nielsen from New Mexico State University is going to moderate, and I will hand things over to Eric.
Don. All right, so we're going to talk a little about what a planet is, which seems like a good way to start off this workshop here. I want to make sure I introduce my panelists here. So from here in Caltech, we have Mike Brown. Make sure I got the institutions correct here. Next up, we have Sally Dodson-Robinson from University of Delaware. We have Matthew Penny from LSU. And connecting remotely, wonderful, I see you, Todd Henry from Georgia State University. All right. So rather than trying to sort of build up to it, let's dive right into the charge of our panel. What is a planet? So the IAU defined this a few years back for a planet in our own solar system. I'm just going to read this right off the webpage here. A planet is a celestial body that is in orbit around the sun, has sufficient mass for its self-gravity to overcome rigid body forces so that it assumes a hydrostatic equilibrium, which means nearly round shape, and C, has cleared the neighborhood around his planet, around his orbits. So that's the planet in our old solar system. The IAU came back in 2018 with the definition of an exoplanet, which has to follow those general lower mass limits, but also has to be below 13 Jupiter masses for below deuterium fusion, and has to be at least 1/25th as massive as the thing it orbits. Okay, so if that's the case, this panel is going to be very short because all the work has been done for us. So I wanted to kick things off with, do you agree with those definitions? Do you see other modifications you would like? Or is that sort of a good starting point?
So I'm the only one holding microphone, so I guess I get to go first. I think those are some of the dumbest things I've heard. I'll start with the solar system one. I mean, as you might know, I'm happy with the way that definition ended up describing the solar system, but I think it's not just a bad definition. It's actually bad to have a definition of the word planet with a three-part lawyerly set of things that you must satisfy. We don't do this in astronomy. There is no definition for galaxy that the IAU has a checklist that you have to say that this fits or doesn't fit. There's no definition for, I can't think of anything in astronomy of an object that is defined. We work in concepts. And I think that works much better for planet. We have an idea of what we mean when we talk about planets. And in our solar system, I think that tried to explain that idea. It's the large dominant bodies in the system. But if you write down a lawyerly definition, then you get literally lawyers writing to you saying, oh, well, there are asteroids that cross the Earth's orbit, so it's clearly not a planet. And you're like, no, that's dumb. And on the upper size, which I haven't thought as much about, that the 13 Jupiter masses deuterium burning is equally dumb. We were talking about this a second ago, and like you'll see a plot of eccentricity versus mass, and it ends at 13 Jupiter masses because there are no planets after that. But if you just extend it, it does other things. So it's crazy to have these definitions. We should not think about what is defined to be a planet. We should think about what these things are out there and what we mean when we say these things.
I agree with everything Mike said, and I would I would like to point out that I'm gonna age myself a little bit, but I started grad school more than 20 years ago, and this question was being hotly debated back then. And so if more than 2 decades later, we are still asking the same question, and despite all the scientific discoveries that we've made since then, we don't have an answer. Maybe it's time to put the question to rest. The question is notoriously slippery because no matter what criterion you give, you can give a counterexample. And Mike gave one for the Earth. I'll add one. For a body that's supposed to have enough self-gravity to be spherical, well, whether it will be spherical or not doesn't just depend on the mass, it also depends on the composition. So you can have an icy body and a rocky body that are the same mass, but the icy body is spherical and the rocky body is not because of material strength. So there is always a way to get around whatever specific point there is in the definition, which I think argues for thinking about it in terms of concepts and not in terms of bullet points on a list.
So once again, I'm not going to disagree with Mike. He summed up pretty much my thoughts pretty well. I'll go into, rather than repeating the same things, I'll just try and go into why I think I was invited on this panel. So I work on gravitational microlensing, and one of the things we can find is free floating planets. So this is maybe one of those points where you could start to argue. Yep, sorry about that. I hate my own voice, so just tell me to keep putting it closer when I move it away. So yeah, these are objects that are on their own out in space, and we will learn very little about them, each individual object, except maybe that it exists and maybe some information about its mass. But if we can put that mass in a regime where it's clearly in the planetary regime, then it seems like something you would call a planet. But then there's going to be some things near the top of the mass limit or the mass range where you'll struggle to differentiate it from a star and certainly from brown dwarfs. So my personal opinion is that the definition is maybe something that should be done from formation mechanisms rather than properties, but that is almost impossible to do, especially in the field that I work in, because you have very little information. So yeah, those are my feelings.
All right. Todd, what are your thoughts?
Well, let me make this interesting. I actually think the folks in the IAU panel, I was not one of them, did a pretty good job in giving us at least a framework. Now, I'm not going to say that every legalese twist, and that's the same way I thought about it when it first came out, is perfect. But I think it's important to give a framework as to what you want to think of as a planet. And that's why all of the young people in the room are sitting there saying, I don't know what to think here. So remember that the word planet comes from the Greek, right? Which is wanderer. We all know that. And when the Greeks were looking up at the sky, they didn't really know what a planet was versus a star. So in fact, it actually meant a wandering stellar object is what the original word meant. And being one of the few people maybe in this conference, if the only one who worked with Carl Sagan, I'm going to go back to historical context and say that that historical context is important. So I think the wandering part is important, but you have to be careful with that too, because I work on nearby stars and they all wander. It's just not at a level that the Greeks could see with their eyes. So you have to be careful with any definition you come up with. And what I would like to do is offer a compromise position which is what I teach in the planetary sciences class when I go through this with graduate students. And if anybody is sitting next to Karina Kamani Stewart, she suffered through that class, and she knows that I like to use the word worlds, because worlds encompasses a lot more kinds of objects, including the Titans and the Plutos and the Erises and even the asteroids, whether or not they're spherical. So I think worlds is a better word, and planet we might want to reserve for things that we've thought of through history as sort of the 8 bodies that go around the sun. I realize that the definition is incredibly solar system centric, but I don't think it's too much of a stretch to put the letters exo in front of the word planet and get to similar kinds of objects in other solar systems. But I do think it's useful for astronomers to continue debating the point. And we would not even have this panel probably if there weren't a definition out there that some people don't like. So that's good. It's just like the whole scenario we went through 20 years ago when Pluto got demoted, as some people say, although I think it got promoted to being number 1 of a large class of objects instead of number 9 and being the runt of the family. So I think the word planet and the definition that the IU's come up with was done by a lot of smart people, worked on it really hard. Nobody loves it, but I think it's a fair framework.
All right. All right. Good debate already. I really like it. All right. And this has led in very nicely to the second question I have, which a lot of people have already touched on, which is it important that we have an agreed upon definition of planet? Or is it okay that I think of, a planet as something different than other people? And I'll try to switch up the starting order. So Sally, any thoughts on, having an agreed upon definition, or just we can all think of it in our own way?
I think the context in which the agreed upon definition matters the most is when you're applying for funding. Should you apply to the exoplanets program or or should you apply to ADAP? I think that is I think that's when people care the most about what a planet actually is, honestly. But I mean, so I like Matthew's suggestion of thinking about it in terms of formation mechanism. But then the problem is if you go in that direction, there isn't a consensus on how planets form. There isn't even really a consensus on how planets of a certain type form. Like, for example, super Earths. I don't think anybody can point to a super Earth pathway and say, like, this is how it works. This is how you build a super Earth. And so I think it's inevitable anyway that when people think of the word planet, they are going to be thinking of different things. I don't think there's any way to fix that because you've got theorists out there who don't agree with each other and have different ideas. And then you've got observers out there who are using different techniques. And, so to a direct imaging person, a planet looks different than to a radial velocity person and to a transit person. So it might be easier to have conversations if we all knew what a planet was, but I think if we knew that for sure, then we might already be done with the work in this field, in which case it would be no fun.
So I think that can you remind me of a question? Because I'm going to go up.
The question was, how important is that we agree on a definition of planets?
Right. Yes. I don't think it's important. I think it's good that we disagree. So I think one of the things that I find myself having to fight against is that if you do hold a definition in your head, it leads you to potentially thinking a little bit too closely to that definition and not thinking outside of it. So I'm constantly fighting the urge to kind of box myself in, and to, like, again, with microlensing, you tend to want to put a mass ratio limit on your planet definition, but you really should be counting everything that could potentially be a planet when you're doing the analysis. And it adds more work. So there's a strong incentive to try and box yourself in. But that's the thing that I'm fighting whenever I'm working. So I think it's good that we disagree and have that constant reminder that we need to think carefully about it.
All right, great. Todd, how do you feel about that?
Definitions are sometimes useful, but I believe in equity, inclusion, and diversity. So I'm not going to rule out any planets out there. I do think that this brings up the memory of the great Vera Rubin approaching me after giving a talk at Carnegie when I was giving talks about brown dwarfs long before we had all these planets. And she said, I don't really care what you call it, but we just need to go out and find them and figure out what they're all about. So I'm gonna go with Vera on this one and go with the same direction with planets. I don't really care what we call them as long as we go out there and figure out what they're all about. So whether or not we actually have an agreed upon definition, it's not that important. There's a diversity of stuff going on out there. Let's just keep talking about them as they exist and worry about the words not so much.
Mike, do we need a definition? Do we have to agree on it?
I was thinking about a conversation I had with someone when we were back having the Pluto debate, who insisted that we needed an agreed upon definition, and their example for why we needed one. He's like, what if somebody goes out and finds two Jupiter mass objects orbiting each other around a star? How are we going to know if we should call it a planet or not? And I was like, dude, that is literally the dumbest question you should ask yourself if you go off and discover these things. Like, it's sort of what Todd's saying. I don't care what you call it. This is interesting. You want to understand what's going on. So no, I don't think we need to make boxes so that we know ahead of time where we can put all of our things. We need to go out and find all the things and then think about how they got there and what they're telling us about the universe out there.
All right, nice. All right, but before we move on, yeah, sure. There'll be more time for questions afterward.
One of the reasons that's often cited why we need to get our act together and define a planet is public communication. Are we going to confuse the public? Are they going to get the perception that scientists don't know what we're doing if we have an ambiguous definition, or if the definition they learned in school turns out to be wrong? So what are your thoughts about that application?
Look, can I answer that one? Because this was a critical point in the Pluto debate. The only reason that the debate about that side, the lower limit on the planets, ever happened is because there needed to be a public statement about whether Pluto was a planet or not. That was the entire reason. And it's because everybody knows the planets in our solar system. This is our neighborhood, and the kids need to memorize their planets, and they needed to know what it was going to be, and they needed to have textbooks. And so it was important to have a statement, maybe not a definition, maybe not a three-part lawyerly definition, but on this side, there needed to be a statement of what was a planet and what was not a planet in our solar system. And I think the public really wanted that. I'm not as sure about the upper end, but that certainly on the lower end, that's true.
Anyone else want to weigh in on that one?
So I'll just say I run public viewing nights at our telescope at LSU, and I get assets it gets mentioned by someone at every event that we do. But I think that's good. That's a conversation starter. The public might have a different idea to us, although there's probably a strong bias towards those that are unhappy with the decision to demote Pluto, apparently, or so-called demote. So yeah, it's a conversation starter, and it's people are interested and want to talk about it. So it's a great opportunity to talk about it.
I think it's the single most useful astronomical thing to have happened for all of us in the last 40 years, because it jumpstarts conversations about astronomy like nothing else does, except maybe life in the universe and aliens landing in your backyard kind of stuff. So at least this one is pretty well grounded as far as conversations go. And if we hadn't had the definition come out, we wouldn't have as many questions. And if it hadn't happened that Pluto got promoted, as I call it, we wouldn't be having these conversations. And so anytime you get this chance, I would encourage everybody in the room there going forward, because I know that kids these days, at least I've run into them, they still have the question, even though Pluto hasn't been a planet theory, by definition for 20 years or so, young kids still want to know, is Pluto a planet or not? So it's still in the the psyche of society. And we should use that opportunity every time we get to talk about what a planet is, what a planet isn't. What do you think? That's always the question to ask them. And whether or not they know that there's a whole Kuiper belt or any other large structure out there in the solar system. I think it's a great opportunity that we shouldn't let slip by.
The one thing I wanted to add is whenever I teach intro astronomy as a general education class, I do one class on what is a planet. And it is the one time all semester that I'm pretty sure all the students are paying attention to me. And I actually really enjoy showing the definition of a planet and then giving these examples that confound the definition and saying, but look, what if we have an Earth crossing asteroid, right? And so I think it gives them a feeling for what is the complexity of science. And also the fact that this is still an evolving field and scientists are still answering questions. Like the textbooks have not been fully written yet. And I think that really helps them.
All right. Thank you. All right. Before we move on to the next discussion question, I do have a lightning round, and I'm going to ask for one word answers to this question. How many planets are in the solar system?
9.
8.
8.
8.
All right. Anyone want to expand on the disagreement?
You guys forgot about Planet 9.
Find it first.
Ditto.
All right. Lightning round complete. Thank you. All right. No, all right. So number 3, we touched on this one as well. Should we be defining planets based on observables? For example, if you measure the mass, if you measure its major axis, should you then be confident it's a planet or something else? Or should it be based on formation? For example, did it form like a planet? Did it form like a planetesimal? Did it form like a star? How important is we have an observable based definition versus a formation based definition, if we have a definition at all? And moving down the line, Matthew, you want to take the first shot at this one?
So I kind of already gave my opinion, but as I said, I think the formation derivation of the definition is attractive because it relies on physical processes, but it's challenging because you actually don't know how some of them formed. So it does lead you to kind of try and fit things in a box with the parameters that you can measure. But even then, with the different techniques, you can't easily translate between them because you only have limited information. So yeah, in the best case scenario, we have a transiting exoplanet with radial velocities and some atmospheric properties as well. But even then, you don't know everything. And if you are to bring it back to demographics, which is the focus of this meeting, if you want to survey the entire space of possible planetary architectures, you need to be able to do the translation between the parameters. And so yeah, the definitions are helpful, but you quickly get into a morass of trying to figure out what's equivalent, how do you translate between mass ratio, m sin I, radius, if you don't have a radial velocity, and it's very hard. So I think being as open and trying to find ways that you can do that translation is the way to go.
Thanks. Todd, any opinions there?
I'm going to second pretty much everything Matthew said. Formation is really tricky, and oftentimes you're not going to be able to figure it out as to whether or not that thing formed like a planet or a star or something else. And I think we have a really good lesson from the brown dwarf regime in this, because for years, people have said that brown dwarfs form like stars. And yet, if you look at brown dwarfs as companions to stars and compare them to stars as compared to companions of stars and planets as compared to stars, you will find out that brown dwarfs form like brown dwarfs. they don't form like planets, and they don't necessarily form like stars either. So the formation thing is always going to be tricky at best. So I do think that having some definition, we all know the difference between a star and a brown dwarf, I think, if you use the mass definition, because one of them burns deuterium in a significant way and one of them doesn't. Sorry, burns hydrogen in a significant way, and one of them doesn't. Only burns deuterium in the case of brown dwarfs. The dividing line between a brown dwarf and a planet, astrophysically, is tougher, but you can use the deuterium burning as that dividing line at 13 Jupiter masses-ish, depending on convective properties and all that sort of thing. So I think the broad guidelines are useful. I don't know that the details are useful. And I think that formation definitions are a trap.
All right, Mike.
I think I am totally on team formation mechanism, and it's tough because we don't know. But I think stars are things that form like stars, and planets are things that form like planets, and we don't necessarily know what all that means. And I think that means that if you find something microlensing and it's kind of in that weird transition point, the right response is, we don't know if it's a star or a planet. The right response is not like, oh, if we measure the mass precisely and it's 12.99, then we'll call it a planet. And if it's 13.01 or whatever your favorite numbers are, we're going to call it a star. I mean, that makes no sense, right? You haven't learned anything by doing that. But I think we're trying to understand these objects, and we understand them by realizing what we're trying to figure out, which is, I think, things like formation, and then realizing that there might be overlaps in some of the observable parameters. I'm sure there are things that form like stars or brown dwarfs that go down lower mass, things that form like planets that go to higher masses. Ignoring those overlaps just doesn't seem like a good way for understanding what we're trying to understand about the universe around us.
I think whether you should use a formation or an observable based definition depends on the science you're doing, because if you are making planet formation models, if you are a theorist and what you're trying to do is simulate the process from scratch, then I would say absolutely do a formation base. So you have a planet formation pathway that's bottom up, then you have a star formation pathway that's top down, and then maybe there's this intermediate brown dwarf mechanism, which could be disk instability. On the other hand, if you're an observer, it's desperately difficult to backtrack to a formation pathway for a particular object. So the more information you have about it, the better you can do it. Like, for example, if you have an atmosphere, you can do abundance ratios, and that helps a lot. Although I will say, I've seen papers that predict the exact opposite thing. Like, I've seen papers that predict C to O ratios are high for planets that form beyond the ice line. I've seen papers that predict C to O ratios are low for planets that form beyond the ice line. So it is very hard to actually apply a formation definition to an observation. And at the upper end of the mass limit, if you don't have both a mass and a radius measurement, then you're going to struggle, because the mass radius relationship flattens out. So you could have a 10 Jupiter mass, 100 Jupiter mass, and 1,000 Jupiter mass object that all have the same radius. So it becomes very tricky to apply a formation-based definition if you're looking at observational data.
All right.
Can I just add one last thing? I think that one of the things that we need to get comfortable with is to be able to say, we don't know. Is this a planet? We're not sure. Here's why we think it might be, but it might be this instead. And that's okay. You don't have to declare everything either a planet or a not planet. I think uncertainty is honest.
And can I add as well? I think there's probably, especially at the high mass end, there's probably at least 3 different ways to produce a Jupiter mass object, but every observable we can get at is going to be the same. I think maybe somebody who knows more can argue with me on that, but I'm pretty sure within the uncertainties that we have, it's going to be tough.
All right. Okay, so another question here is, given what you work on, when someone says the word planet to you, what's the picture you have? And just to sort of get things rolling, I work on direct imaging. And so if one of my colleagues says, I just found a planet, I'm going to instantly have a picture of something that's, Jupiter mass or larger, is probably going to orbit tens of AU away from its star. It's probably going to orbit a star that's less than 100 million years old. That's just sort of what planet means to me. But what does it mean? When you hear the word planet, what's the first thing you think of? And Todd, why don't you kick us off?
First thing I think of planet, I think of the course I have to teach and try to explain all this to smart graduate students and not get myself in trouble all the time. But I come from a planetary background. My undergrad stuff was planetary sciences, and then I leapt over to stellar stuff, and the exoplanet stuff I'm coming to now. So I probably have all kinds of definitions, and I haven't really all kinds of thoughts about what it comes down to. I would say the first time, if you mention planet, I'm going to think Earth. And the second thing I'll think of is probably Titan, even though I would call that a world, not a planet. So I'm not going to have the same sort of thought in my head, probably, that the folks who are doing exoplanets all the time have.
All right, nice. Mike?
Yeah, I feel a little like Todd here. I'm not even sure what I think I work on all the different planets in our solar system and all the different worlds in our solar system. And so not too many people in the solar system say, I just found a new planet. But if you did, I would think of like a large Neptune sized thing really far away. So I don't know, there are all sorts of planets, and I think about them all and love each one of them in their own special way, except for Mars. I hate Mars.
Sally, you don't have to respond to that if you don't want to.
So I'm going to give you an honest answer, which is nevertheless something that Eric isn't expecting. But for the past 5 years, I've been working on planet validation tools. So figuring out, do you have a planet? Do you have a stellar signal? Do you have a false positive that just comes from your frequency domain methods? And so now whenever I hear about a planet discovery, especially an RV one, what I think is it real?
All right, Matthew.
I like that. So I think there's nothing that instantly comes to my mind except maybe Earth, but just the diversity of possible planets. So especially when I'm giving talks to the public, I spend a lot of time just re-looking over the kind of 2-scale diagrams to try and put myself in the mindset of just how huge the solar system is compared to our kind of everyday. And so I start off with kind of just trying to get that across to everyone, and I'm sure I failed pretty miserably. But the other thing that I like, or that I wanted to bring up in response to this question is artist impressions. I think they're really valuable for connecting. They're all wrong, right? You can probably very quickly point out something that doesn't match what we know about the planet in every artist's impression. But it's given that we are used to looking at these kind of very obscure signals, it's the way that we often have to communicate our discoveries. And I think it's I from a very young age, I have enjoyed looking at kind of visualizations of what planets are and planets outside the solar system. And so maybe I'll make that my answer, is the artist's impressions that we get, despite how wrong they probably are.
All right. Okay, so when lawyers give advice to other lawyers, they always say, never ask a question in court if you don't already know the answer. So I'm going to start out by asking Mike a question that I'm pretty sure I know the answer to. What past discovery do you think has been most important in changing your personal definition of planets?
I think you think I'm going to say Eris, but you're wrong, because Eris didn't change what I thought about Pluto. I already thought Pluto was not a planet. As soon as the Kuiper Belt was discovered, the first object was discovered in 1992, and some people dismissed it as just a fluke. And then after like just about 3-4 years, there were enough objects that it was very clear that Pluto belonged to this class of objects, and it didn't make any sense to have it be a planet. So I would say the object that really changed my idea of what a planet is that first Kuiper Belt object, 1992 QB1. It was named, and that's really what set the ball rolling for probably the entire the panel discussion we're having today.
Sally, any past discoveries changing your personal definition of planets?
The ones that I think don't get enough attention and that I always struggle with are the pulsar planets. Every time I think about those, I just think, but we just leave them out of the conversation, but yet they were the first. And so I think we should include them and think about, are there more of these out there?
Those are both really good answers, and I'm not going to be able to beat them. But I will say I was probably too young. I definitely wasn't doing research at the time the IAU decision came out. So I'm not sure there is anything that has really changed my definition. At least maybe I was like more of a member of the public when the Pluto controversy happened. So I guess that is probably it.
All right, Todd, anything, any past discoveries?
Yeah, certainly the pulsar planets were a watershed moment. There's no doubt of that. I think the other thing that maybe got me to shift, Eris is the debate topic, but it's all these hot Jupiters. We just didn't quite see that coming, and I think that caught all of us in the '90s off guard. And I don't know if folks, probably not a lot of people in the room remember this, but there was a lot of contention about 51 peg for a while. People publishing articles saying, no, it's not real, it's not really there, or it's something else, or it's the star. And so going through that mindset for a few years until some more of them started popping up. And then all of a sudden we had this whole class of objects that people said, wait, how in the world did this happen? So I think that shifted what I thought of as a planet.
All right. And I have one last question before I turn it over to the audience for more questions. This is the speculative one. What future observations, future observatories, future telescopes do you think could lead us to reopen the definition of planet once more? Sally.
I'm going to have to, I don't think I have an answer for that one actually, because maybe Nancy Grace Roman actually, because that's when we're going to start to see, real microlensing statistics. That's maybe that's a frontier for sure. And also Gaia with the astrometry, that's another frontier. But I don't think that there's anything we've talked about today that isn't in my thoughts when I think what could be a planet. So in terms of reopening the definition, I'm not sure what would do that.
So Sally did my sales pitch job for me. So I'll say the interstellar objects that we're now starting to see. I think we're going to get more, obviously, with Rubin and Roman. They'll both really help with this. And I'm excited to see how big they can get. We're fighting a pretty strong power law, I think, if the solar system is representative, but if we can keep those facilities running for a long time, we can find them out to larger distances in the solar system as they pass through. I think those will really help shape our idea of what is out there and what gets kicked out of other planetary systems.
All right, Todd, future discoveries.
I'm going to make a bold prediction in that Sally touched on it. Gaia is going to break things open because the number of confirmed planets now is sort of in the 5,000, 6,000 range. Gaia is expected to do way more than that, maybe tens of thousands of candidate planets. If that turns out to be the case, everything's going to change.
And Mike.
Including the NASA Exoplanet Archive, which I've been harping on them for a couple of years now. They need to get ready for this.
So I'll restrict myself to the solar system on this one and say I don't think anything's going to change. I mean, so maybe we find some other distant eccentric planets, but they're going to be things that we understand. They're sort of mundane, gas giant kind of stuff. I don't think anything that's discovered is going to really make us rethink what is a planet anymore in the solar system. I think we're kind of done.
All right, excellent. So we have about 15 minutes left. So I'm just going to open up to the floor now. If anyone in this room would like to pose a question to the panel, either one panelist, multiple panelists, or anyone online, please go ahead now.
I think Matthew touched on something interesting that I think will start to come, is we're now starting to see these interstellar objects coming in. So there's now presumably a mass function that after we have 2 or 3 more, people will be extrapolating upwards and downwards. I know. But it comes to the question of when we start then getting the microlensing results on free-floating Earths, what do we say about a free-floating Earth other than it's got to be really sad to live there? But, they're not orbiting anything else. Maybe they're round, maybe they're not, but we know they have a mass and they're just floating in space, assuming they're not attached to some very distant star. But if they really are free floating, presumably they've been ejected or something else, are they a planet? Are they an interstellar comet? What do we do with them?
Sure.
I need an answer.
I feel like that was directed at me, so maybe I should try. So yeah, I agree. This is why I'm doing this, is to try and expand that our imaginations a little bit on what a planet can be. I think where the thing that most interests me is kind of the violent processes that can get you to kick out a planet that large. How do you do it? And we need numbers and a mass function to really start to get at it, which was just about starting to do. And Roman will again hopefully multiply the rate at which we can do it. Sorry. Yeah, that's about all I have.
Let me give a little answer too, which is that in the end, when we find these things, the questions we have are how did they get there? How did they form? And worrying about do we call it a planet or not is really one of the least interesting things we can do. If it formed in a planetary system and got ejected, I'm perfectly happy to call it a planet even after it's get ejected. I don't think you suddenly change what you are. But really, that's what we'll do. We'll see these things. We'll be like, wow, people start trying to understand if the masses make sense, if there's some weird way they can form in interstellar space, and that's what we'll care about.
Just call them all worlds, Chaz. Don't make it hard.
Testing. There we go. Hi, I'm Ashley. I'm a graduate student at Louisiana State University. So I had a question. If you had unlimited funding, unlimited technology, whatever, what kind of instrument would you want to see built to help further the field of exoplanet science?
Well, like probably everybody, a little bit frightened with what's going on with the funding situation for science. And so what I would say is protect Habitable Worlds Observatory. If you could do that, then that'll be fantastic. And the next generation of astronomers will have plenty of data for their entire careers.
If you're going to give me infinite money, I'm going to build 1 million interstellar probes with decent little cameras on them. And wait.
I guess I can split the difference and say something that will go to one of these interstellar visitors that we have going through and kind of get into orbit, and which is hard, and give as much data as we possibly can. because that's the only way that we're going to be able to get kind of in situ data on something that did not form in the solar system.
I want to know why Mike hates Mars.
I kind of feel like anytime you have a planet and you're landing something on a planet and you're taking pictures with something in orbit that's taking pictures of the thing that's landing, that also takes pictures of things that are on the ground, you probably have enough. That's all I'm saying.
I'm going to
You're
disagree
given a
with
talk
Mike
at Cornell.
again. Sorry, I'm going to disagree with Mike again and say I love Mars. I think it's cool.
I wish it was a bit bigger.
I wish it were a bit wetter.
Hi, Brian Jackson, Boise State University. The conversation here about where we put the lines between planets and not planets, I guess I'm sort of comfortable with the idea that there's these fuzzy boundaries. It doesn't really bother me necessarily. Maybe the word planet is kind of context dependent. So I think that's sort of a reasonable approach. I worry or I wonder what we're going to do about finding the first life. If we find something that sort of straddles the line between not alive and alive, how are we going to deal with that situation? Because it seems kind of analogous to this. What is life? What is not life? Are we just going to tell the public maybe it's alive, maybe it's not, or it's sort of proto-life, or it's a dwarf life? I don't know what we would do, how we would deal with that. So I'd be curious to hear folks' thoughts. How does this sort of debate kind of translate into that context?
I would say that the one thing that translates well is that we need to be honest about our uncertainties. Like, we don't know, here's what we see, here's what we think is going on. We think it might be this until we, learn more and more. And I think that is true in the context of the solar system. If we bring things back from Mars and start to look at them in our labs, we'll understand geochemically how things might have evolved, and we'll talk about that. If we see signatures in exoplanets, but in all these cases, the worst thing we can do is jump up and down and say it's life. The best is to say, here's what we think is happening, here's the uncertainties, and it's very exciting, and let's keep going.
If I could add to that, I would say it's really important to tell the public the difference between a biosignature and a discovery of life. And maybe we can figure out a better word than biosignature for science communication. That might be worthwhile. But I think we're going to go through a time when we're finding biosignatures, but we can't go a layer deeper. We're going to have some time where we're stuck on the biosignature level. And so we tell people, well, it's maybe could be life, but I don't know, maybe it's something else. Like, maybe there's a process that produces phosphine on Venus that doesn't operate on Earth, and it's a geological process. And I think that's an opportunity. It's a feature and not a bug, because it tells people, stay tuned, watch this space, and then you keep people wanting to know more. And so I think we should exploit that time when we're dealing with biosignatures to keep people's interest in the field.
It's a fun question, Brian. It's going to be a mess. It's already turning into a mess, and science is messy, and the public is hard to educate about the messiness of science. But I think it's going to be fun for everybody involved, except for maybe the people who run NASA and NSF, because they have to be regimented and answer to the government. But I think we scientists should have a lot of fun with it, because it's going to be a good time.
I'll just say that my microphone's died. I'll just say the stakes are even higher than the planet question, right? Because it also brings in a lot of religious connotations as well, which again these are good conversations to have. They are maybe a bit thornier and harder to have, but they're important ones to engage with.
Yeah, Anna knows a question about distinction between a planet and a moon.
When does something stop being a planet and start being a moon?
When it goes around a planet.
I would like to binary planets are an option as well, and I kind of like that for Pluto and the Earth.
It's not a planet.
Can I point out there's a weirdness in that one too, because the moon is moving away from Earth. And so if you use the definition that if the center of mass of the orbit is contained inside the bigger body, it's a moon orbiting a planet. Whereas if you say, okay, if the center of mass is outside the bigger body, it's a double planet. Well, at some point we will be a double planet system because the moon will be tidally pushed far enough so that the center of mass of the system will be outside the Earth.
And even better, if it were on an eccentric orbit, it would be a planet during half of its orbit and not a planet during the other half, which would be fun.
Her name is Luna, so she's a moon. Luna.
Sorry. Okay, sorry. Any more questions in the room or questions online? Oh, see a question?
I'd like to bring up, we're going to have to address a living planet. That we're going to have a similar debate. Is it like an Earth 2, some sort of planet with life? And we'll have to deal with, maybe Mars or Venus or class 2 or something.
This has been alluded to a little bit already, but given the vast and sparsely explored regions beyond Pluto, what do you think is the possibility that one or more planetary mass objects remain undetected?
So I would say the probability is 99.97%. How's that for a good number? I mean, so the evidence for planet past Neptune, way out there, like 600 AU, something like that, you can read headlines that suggest otherwise, but it's because everybody loves to write those headlines. The evidence just keeps getting stronger. It's very difficult to understand the dynamics of the solar system without having that additional mass out there causing the orbits of things in the Kuiper belt, causing different orbits as they come into the inner solar system. So there's a lot of things that you would have to explain individually if there's not another planet out there. There's I'd say good chance that Vera Rubin finds it if it's on the sort of closer end of where it might be. Otherwise, it's going to be hard. It's kind of far out there. But I think it's pretty clearly there. But I might be a little biased.
So I can't really add any more informed probability, but maybe I might help the discussion by asking Mike, what evidence would you need to say it's not there?
Yeah, so that's a great question. Right now, there are about 5 or 6 different lines of evidence that point to it being there. And what you really, and so this one explanation, which is, let me say, a mundane explanation. There's another planet that got scattered outward that's a little bit of a sort of sub-Neptune mass. Like, if you saw this around any other star, you would not think twice that this was very interesting. I mean, interesting, sure, but not surprising. The idea that we might have something like that around our sun is only surprising because we think we would have, we didn't think about it before. So right now, there's one planet that can explain all these kind of 5 disparate things, and most of them have no other good explanation. So really, to show that this planet's not there, what you would really want is actual explanations for all these weird phenomena that we can't explain otherwise. So right now, it's just the best, easiest hypothesis to explain this. But if you can find other ones, then this one can go away.
And then, assuming it is real, is it the planet from the NEATS model that got kicked out and led to the giant planets moving?
I like to think yes. So, you know, in the models of the formation of the solar system that are favored these days, there's a fifth giant planet and it gets kicked out and it causes all kinds of havoc. It would be very natural if that were then captured at the edge of our solar system, presumably from stellar encounters, from formation in a cluster. It need not be, though, because most of the other models suggest that the process of kicking out sort of that size planet, that there might have been tens of them that were kicked out as the solar system was forming. So it could have been a different one, but it's kind of fun to think it's that one. I hope that we find it relatively soon so we can start to study it and learn about, try to figure out where it came from and things like that. It'll be fun.
All right, I think we have time for one last question, either in here or online.
Have another one from online. If each of the panelists could theoretically visit or probe an exoplanetary system, which system would they choose?
I'm gonna go to Planet 9. It's not an exoplanet, but it's kind of cool.
I'd like to see the 55 Cancri system because one of my students has been studying that and he has some really interesting results. So I'd like to know if he's right.
I'll give another relatively expected answer. So TRAPPIST-1, I think, would be really interesting because you have so many similar planets so close in to, it's kind of straddling the habitable zone to see how the range of atmospheres on small Earth-like things varies. That would be very good.
Well, apparently the puppies have their own opinion. You know, TRAPPIST-1 is sort of the one I think of first, but I'd also like to go to Proxima because I want to see what's really going on there. And I also want to be able to look back at our solar system and get some perspective of what it looks like from afar. And I would honestly like to wake up in the morning and see Alpha Centauri A and B bright in the sky and see if there's anything else small there that's still hiding that we haven't really picked up yet. You get 3 stars for the price of 1.
All right, and as chair's prerogative, I'll end off with 51 Eridani B, beautiful young analog of our own giant planets. You know, we've got so much information out of it from essentially 1 pixel. Imagine being able to actually resolve the surface, see if there's any moons. What does a very young Jupiter analog look like? All right, I would just want to say thank you to the panelists again. It was a really great discussion. So a big round of applause for everyone here.
All right. And I want to thank Eric too for moderating. So thanks, everybody.